Welcome you all, dear students. In the last class we discussed about axial deformation, that prismatic bar. Now in this class we will derive an expression, one more derivation. You can write the heading as derive an expression for, one minute. Okay. We'll discuss that derive an expression for, put the heading, derive an expression for axial deformation only due to self weight, okay. This is a derivation, this is the heading, and let us consider, you can write down the points here. Let us consider hanging prismatic bar, write it in words first, okay. Let us consider hanging prismatic bar with cross sectional area A with the length L with the material property Young's modulus E, okay, and the prismatic bar which has unit weight gamma and its complete weight as a W. Unit weight means it's like a density. It is like a density, okay. And it is a complete weight means just we are measuring the weight of that. Let it be W and this be gamma, okay. Now, these informations we got. Now, when we hold this particular bar in this way, then because of the self weight, we will observe some elongation in the bar. That elongation we will call delta L. But this delta LS will call, because this is a elongation due to self weight. Therefore, this is a delta LS. We want expression for this delta LS, but no force is pulled here. Therefore, it is very difficult to understand why it is extending its length, right? That is because of self weight. But when I consider this plane, at this point self weight is only this much. When I consider here this much, when I consider this support, the entire self weight is acting. Therefore, the self weight is varying from here to here, and which is actually that making this extension, that is varying from here to here. Therefore, I will consider a small strip in between. This is a very small strip. Therefore, the thickness of the small strip I will call it as a dx. This is a dx. Then where exactly this strip is situated, that I will call it is a x distance from the bottom. This small strip is situated at a distance x from the bottom. Then what is the cross sectional area of the small strip? Again, because it is a prismatic bar means from here to here it is same. Therefore, cross sectional area of the strip is also A only. Okay now if I write the free body diagram for this small strip, how it will be? That small strip will be like this. This is a small strip, and this small strip is in equilibrium. Yes, it is in equilibrium, even though it is in the middle, but it is in equilibrium. Then this small strip is pulled by this much of load. I will show you with a red color. See, this much of bar is there, no? This much of weight which is pulling it down. This much of weight is pulling it down. Therefore, the downward force will be Wx. Wx means the prismatic bar of length x, this is the Wx. Then if it is in equilibrium, then I have to call this will be again Wx. This small prismatic bar, this small strip what we considered, its thickness or its length is dx. Its length is dx. And the weight of the small strip is ignored. Why? Because it is very small, therefore the weight of the small strip is ignored. It is not considered into a vertical direction. Okay. Now, if this small strip extends its length, if this small strip extends this length, let us consider that extended length of the small strip as a delta Lx. Delta Lx. Then I can write the expression for this delta Lx very easily by using the prismatic bar method. Delta Lx equal to PL by A. P here is Wx, L here is dx, then A here is A, and E here is E. Okay, now this is your small strips extension. Now here this Wx is there. Now how to get this Wx from here to here? That I will write here. Always the density is equal to weight by volume. Weight by volume. If I consider a small weight, then the volume is also small. Then this Wx I can write it as Vx into gamma. Vx into gamma. Then what is this Vx? Vx is a small volume which is shaded by a red color. Then this volume I can write it like area into x. That is your area into length is a volume into gamma. Now I got Wx in the place of this I can write. Therefore here Wx means Ax, gamma if I write Aa gets cancelled. Therefore it will be gamma x dx divided by E. Only this much is left. Aa is cancelled. Then this is expression for a small strip. If I want the expression for the complete diagram, then I have to integrate the entire thing. Then integration of delta Lx equal to gamma is a constant and E is a constant. I will take it out. Then integration of x dx. Then the integration of delta x will be delta Ls elongation due to self weight. Then this gamma and E will be constant. Then this integration we are doing from 0 to L, because this x is varying from here 0 till it is varying to L. Therefore it will be x square by 2. Then the limits are 0 to L. Then if I substitute upper limit and lower limit, I will get an expression. Below this you write, I will get an expression delta Ls equal to gamma by E into L square by 2. L square by 2. This is an expression for elongation due to self weight. You can write it like gamma L square by 2E. Now what is gamma? The entire weight if I want to convert, then the same formula I will use, gamma equal to total weight divided by total volume. Then total volume is what? Total volume is area into length. Now if I substitute here gamma L square divided by this gamma I need to write, in the place of gamma I need to write W by AL. Then this L cancels, therefore you will get delta Ls equal to WL upon 2AE, because this 2 is also there. Then this expression you will get it. Either you can use this expression or you can use this expression for elongation due to self weight. This is very important derivation you can expect for examinations. After this we will solve one problem here. For this problem that derivation is not required, but still I will cover this problem in this video only. Now look at here. I told you before starting the previous problem, I told you some guidelines that to happen the deformation, axial deformation or any deformation, the condition of equilibrium is must. Okay, now This you remember. Now read the question. Determine the stress in each section of the bar shown in the following figure when subjected to axial tensile load of 20 kN. The central section of the square cross section, central section is of square cross section, and other portion are of circular section. What will be the total extension of the bar for the bar material E equal to 4 times 0 MPa, and all dimensions are given here. Here something you need to observe here, always we should have area and Young's modulus for all the materials and length. The lengths are given, yes, length is given, this length is given, this length is given. This area is not given, this area is not given, this area is not given. Okay, but here some dimensions are given. 20 mm diameter means this is circular, this 15 mm diameter means this is circular, this is a square of 30 mm square, it is said. Then I will consider this as a one diagram, this as a second diagram, this as a third diagram. Then for the first diagram I will call it as a A1 equal to pi by 4 into 20 square. A1 equal to pi by 4 into 20 square, that is 314. A1 is 314 mm square. Then A2 is a square cross section, therefore 30 into 30. 30 into 30 is 900. 30 into 30 is 900 mm square. Then A3 is again pi by 4 into 15 square. Okay, that is pi by 4 into 15 into 15. That is 176.71. 176.71 mm square. You got areas. And what about E? E1, E2, E3 are same because only one material, that is equal to 2.1 into 10 raised to 5. I can write it, or otherwise directly you write it, no problem. Newton per mm square. I got E1, E2, E3. Then L1 is known to me, L2 is known to me, L3 is also known to me. Okay, now I will consider, I need to analyze what force is pulled for A. Then I will consider a bar A. This bar A is pulling by 20 kilonewton here. Then that bar A will oppose also 20 kilonewton in the opposite direction. Then the extension of bar A will be what? That I will call it as the delta L1, that is your PL by A. PL by A is a common formula, I will write it somewhere, PL by A. Then P is how much? 20 into 10 raised to 3. L is how much? For the first bar L is 250 divided by A is how much? For the first bar A is 314. Then E is how much? 2.1 into 10 raised to 5. Then this is delta L1, that is 20 into 10 raised to 3 into 250 divided by 314 into 2.1 into 10 raised to 5. The answer is 0.071, 0.075 mm. You check it, you also do it and check it. This is right. Okay, this is for first diagram I did it. And the second diagram, if I consider, the second diagram is also pulled by same force 20 kilonewton, because this member is welded to the second bar, therefore whatever the force it is pushed here, it is pulled here, the same amount of experience will be done by B also. Therefore for the second bar is also 20 kilonewton. Therefore delta L2 equal to P 20 into 10 raised to 3. L is 100 mm divided by A, area is 900 mm square, into E 2.1 into 10 raised to 5. The answer is 20 into 10 raised to 3 into 100 divided by 900 into 2.1 into 10 raised to 5. This is 0.0105 mm. This is also tension, therefore positive. This is also tension, therefore positive. Coming to the third bar which is pulled in this direction with a 20 kilonewton, you can see in the figure. Then if it is in equilibrium, then here resistance will be 20 kilonewton. Then delta L3 equal to P 20 into 10 raised to 3 L is here 400 mm divided by area is 176.71 into E 2.1 into 10 raised to 5. The answer is 20 into 10 raised to 3 into 400 equal to divided by 176.71 into 2.1 into 10 raised to 5. This is 0.215 mm. Then all are in tension, therefore we will get total delta equal to delta L1 plus delta L2 plus delta L3 equal to 0.075 plus 0.0105 plus 0.215, right? 0.215. Next, the adding all of them, plus 0.0105 plus 0.075 plus 0.215 is 0.301 mm is your delta L. Okay. See the question, what will be the total extension of the bar? Then this is the total extension of the bar. Hope you understood the problem. Now coming to this problem, it is somewhat very critical, very nice it is. Now see here, determine the overall change in length of the bar shown in the figure below with the following data. Okay, where E is equal to 1 into 10 raised to 5 Newton per mm square. Now here 3000, 30,000, here 20,000, then here 34,000, here 16,000 force are applied, but some force are negative, some force are positive. Therefore, and the lengths are given here, and this is diameter is given, means circular, this is circular, this is circular. First we will work out A1 equal to pi by 4 d square, pi by 4 into 20 square is 314 mm square. Then A2 is pi by 4 14 square, pi by 4 into 14 square, that is into 14 square into 14 into 14, that is 153.86 mm square. Then A3 is pi by 4 10 square, this is 78.5 mm square. Okay, now I have to solve it very carefully, that I will consider the first bar. This we will call as the first bar, this we will call second bar, this we will call third bar. The first bar is pushed by 30 into 10 raised to 3 Newton, correct? 30,000, it is pushed and over. If I consider the section at this point, then at this section if I draw, that section looks like this. Then for this particular section, if a 30,000 is pushing, then the resistance offered by that section is also 30,000. That is also 30,000. That is also 30,000. One more thing you have to check it, before going ahead, we need to check it. Check it here, 30,000. I will write here 30,000 going this direction and 20,000 going this direction and 34,000 going this direction, then 16,000 going this direction. 34 plus 16 is 50, 30 plus 20 is also 50, therefore 50-50 cricket match. No? Therefore 50-50 is there means what? It is equilibrium. Now I will consider this portion if I put here, that portion is pushed by 30 kilonewton, then resistance is also 30 kilonewton. For the first diagram we will not get any difficulty, you know, or otherwise, sir, how I have to think that this is 30 kilonewton? Then see here, this section I will write here, this you understood because it is pushing here. Then in the other direction we will calculate. In other direction, this way it is going 20,000, this way it is going 34,000, then this way it is going 16,000. Then 16 plus 34 is 50,000 is going this direction and this direction 20,000. Then the net result is going this direction 30,000. That 30,000 I wrote here. This 30,000 is given here only. Now you got it. Then calculate delta L1 equal to PL by AE. P into L is how much? 100 mm divided by A is 314 into E is 1 into 10 raised to 5. 1 into 10 raised to 5. This is 3 zeros, 2 zeros, 5 zeros, this cancel. Therefore 30 by 315 is answer. 30 by 314. 30 by 314 is 0.095. 0.095 is compression. We will write in the bracket. This is compression. Now coming to the second diagram, this diagram, that diagram I will write here. And this diagram is pushed by this force, that is 20 kilonewton, and that diagram is again pushed by this 30 also, therefore that is pushed by again 30. And this side if I see, other side, then this is pushed by 34,000, then again pushed by 16,000. Therefore the body is this side pushed by 50,000, this side pushed by 50,000. Therefore PL by AE delta 2 equal to P is 50 into 10 raised to 3, L is 140 divided by A is 153.86 into E 1 into 10 raised to 5. Okay, then this answer is 50 into 10 raised to 3, 50 into 10 raised to 3 into 140 equal to divided by 153.86 into 10 raised to 5. The answer is 0.455. The answer is 0.455. This is also compression. This is also compression. No, this is also compression. We got it. Then the third diagram is here. If I take a section here, then I will get this diagram. That diagram I will write here. Then that diagram is pushed by 16, then it will must resist by 16. Therefore delta L3 equal to PL by AE. P is 16 into 10 raised to 3. L is how much? 150 divided by A. A is how much? 78.5. 78.5 into 1 into 10 raised to 5 is your answer. That is your 16 into 10 raised to 3 into 150 divided by 78.5 into 10 raised to 5. This is 0.30. This is 0.306. mm. This is also a compression. See, therefore all are compression, therefore I can add them. You can call them as a minus also, compression minus tension positive. Then you will have delta L equal to minus 0.095, minus 0.095, because minus is because of compression, minus 0.455, minus 0.455, minus 0.306. The total answer is 0.855 minus 0.855 mm. Okay. What they ask, check it. Determine the overall change in the length. Overall change in the length is minus 0.855. Okay. Thank you very much. See the old year question papers. You will definitely find such question and solve it. If you have any doubts, you can approach me. Here I will give you one homework. Okay. Just you go ahead with this homework. Now this length is 1000 mm, this length is 750 mm, this length is 500 mm. Okay, and this force pushed here 30 kilonewton, this force is pushed here 25 kilonewton, and here one force is there. Here one force is there. That force I don't know. That force I don't know. That is P force it is. I don't know. And here it is pulled by. Here also it is pushed by. Here it is pushed by about 75 kilonewton. This is 75 kilonewton. Then the question is, what is P? What is P and what is total elongation? What is total elongation? Okay. And here I will give A1 is 100 mm square, A2 is 200 mm square, and A3 is 75 mm square. 75 mm square. Okay, now then Young's modulus is 2 into 10 raised to 5 Newton per mm square. Take this as a homework and solve it and send in the WhatsApp group. Thank you very much.